But the good news is that I was hired by my hometown basketball team, the Boston Celtics. Um, I'm proudly rocking their colors today. So, for those of you who don't know, the Celtics are, of course, the greatest franchise in NBA history. They have the most wins and also the most championships. But unfortunately, in the last decade or so, they've fallen on harder times. Um, they haven't won a championship since 2008. And then to add insult to injury, just in the last year alone, the Lakers, our fiercest rival, won a championship. And then the Celtics got, just last month, embarrassed by the Brooklyn Nets. They won one game out of five. And the day after that, our general manager quit and was replaced by the head coach who has no front office experience. So, the Celtics, of course, knew that me being a thought leader in the data science basketball space, they reached out to me and hired me as a consultant to negotiate this new era. And specifically, the question they wanted me to work on was, since they need to sign free agents, they need to improve the team. They wanted me to figure out if I can predict a player's free agent salary from his previous season statistics and also his previous season salary. So in other words, they want to know, is there a simple way to tell the market value of players just based on past stats? And that will tell you if a player is being overpaid or underpaid, how much to offer them, things of that nature. So as an example, here we have Kevin Durant, and if we go to his basketball reference page, we see some information: his height, his weight, which could be useful, his position, his nickname Durantula, which is probably not as useful for predicting his salary, but still hilarious. And then, of course, there's a bunch of other stats that are actually useful. So all sorts of per game statistics, cumulative statistics, advanced statistics, his salaries over the years, things like that we can scrape and see what happens. So let's find out. So here's my workflow for scraping. I use Beautiful Soup. So I wanted to get data for many years. So for a given year, there's this handy webpage that tells you all the free agents for that year. And for those who don't know basketball, a free agent is exactly what it sounds like. It's someone who is free to sign with any team, as opposed to someone who is going through a 4-year contract, for example, where their salary doesn't change. So let's look at 2019. We have 287 free agents, so we can go row by row. So Kevin Durant comes up first. And then to get our features, we can get his salary from the last year from another website called Hoops Hype. And then we can go to Basketball Reference to the Kevin Durant page and get whatever stats we want. And then for our target, we want to predict his next year's salary, also from Hoops Hype. So 2 websites, bunch of tables. And to be honest, the data cleaning is actually the part of this project that I'm the most proud of. It was a nightmare. First of all, you have to take into account players who switch teams in the middle of the season, players who have weird, non alphanumeric characters in their names, like C's with little squiggles and whatnot, that are very hard to scrape. And of course, there's the usual products of duplicates and nulls, which also have to be dealt with gracefully. And then, so I did some obvious things like removed all the players who, either are not playing next year, they didn't sign a contract, or they're out of the league, or didn't play the previous year. And then I did some other things. So, for example, one thing that you might not know about the NBA is that there's a salary cap. Every team has a fixed amount of money that they can spend on players, and that amount actually increases every year. So if I were to not normalize by the salary cap, then every year players would get more and more expensive, and that would add some problems to our data. And more specifically, I actually, ideally as a data scientist, you want to scrape as many rows as humanly possible. We're all, ravenous for data. But there's a couple of reasons why I limited myself to just the last 4 years. One is that you can see from from 2016 to 2017, there was a huge jump in the salary cap due to a giant TV contract being signed and a lot more revenue for the league. As a result of this jump, a lot of teams had a lot of money, and it was just a feeding frenzy. Guys like Timothy Mozgov were getting $20 million a year, and of course the Golden State Warriors were able to have a once-in-a-lifetime opportunity to put together a juggernaut. So I didn't want to include that year because I felt like that would mess with my data. And not only that, but over time, what people look at for teams actually changes. So, back in the day, you would want pass-first point guards. Now you want them to shoot. So I didn't want to bias the data too much, so I decided 4 years would be perfect. And after, after all that, I ended up with a beautiful data set. Has no null values, and honestly, I don't think a single value in it doesn't make sense. I would go to war with this data set. And before I talk about regression, I just want to say that the features I decided to scrape are actually actual numbers. How many assists, how many points, how many turnovers, shooting percentage. There's a lot of advanced statistics such as win shares, which Will talked about, and also things like VORP, which stands for value over replacement player, and PER, which is another metric. And all of those metrics they're models in themselves. So I didn't want to use, I didn't want someone else telling me what a player's value was. I wanted the model to figure it out just from the raw data. So I didn't use any of what I call cheating statistics. They're fine for targets. I don't think they're good for features. So for feature engineering, I looked at the usual stuff, correlation matrix, the p-values from stats models, the pair plots to look for any patterns in the data. I removed some features that had very low p-values. I added some polynomial terms from the pair plots, so points per game especially looked very square, not linear. I added some ratio terms which made sense to me. So for example, if a player plays 50 games, does he start all of them? Is he riding the bench? I felt like that would be important. Turnover to assist ratio, things like that. And you can see in this correlation matrix that there's a lot of multicollinearity present. I think I pronounced that correctly. And so so we have to deal with that. So the first model I did was just a very vanilla, five-fold cross-validated ordinary least squares. And here we got our predicted versus the salary. We can see that we have a train R squared of 73, a test R squared of 66, and our errors are about 4 million a year, 4 million per player, absolute error around 5 million squared error. And you can see in the residuals that there's some pattern here, which is not ideal. And then, of course, I wanted to try a fancier model also, because that's what we're here for. So I tried a cross-validated regularized lasso model. And you can actually see that it looks like almost identical. Honestly, for example, the residuals, this looks like this flipped. It's not. I looked at the points, they're different, but it really does. And the R squared is very similar, the absolute error is similar, the squared error is also similar, so it really didn't add much. But it adds one thing, it adds interpretability. So I was very curious to see which coefficients got zeroed out. Here is a plot of our coefficients. So I was very happy to see that the two feature engineered features which I introduced were actually the highest coefficients. So the points squared and the minutes per game squared. Turnovers are penalized. No one wants someone who turns the ball over. Previous salary didn't seem to affect next salary that much, which was interesting. And a few other things that I thought were cool. I was surprised that my percentage of games started was zeroed out. Things like that. But the big takeaway here is that by far the most important feature, just by far, is going to be the points scored. And I have some thoughts on how to tighten and extend this model a little bit. But based on this lasso coefficient, I wanted to leave you with the last word to go to Celtics legend Bill Russell.
What these young bloods have to understand, that this game has always been and will always be about buckets.